Hi, welcome back. In this lesson, we're going to introduce you to the components that make up an ISE deployment, help you understand the different node types, deployment models, and high availability. This lesson builds the foundation for almost every ISE deployment, so it's an important one. Let's go ahead and get started. This is my standard disclaimer. The information that we're going to be talking about is based on the most current ISE version, which is either 2.4 or 2.6. When you're going through and designing your environment, make sure you're always looking at the latest release notes and documentation for the specific version that you're implementing, as there may be small changes or things that have been added that are not talked about in this session. So please make sure you're always looking at the release notes for the current version that you're deploying. So how do I figure out what type of deployment I'm going to have? There's a number of different things that make up a deployment. How many endpoints do I have? A lot of people seem to think this is just endpoints connected to their workstations, right? They kind of forget about phones. They forget about other IoT devices like printers, cameras, HVAC systems. So make sure that you keep in mind every type of endpoint that might be connecting to the network. Where are my resources at? Are they global resources? Are they regional resources? Keep all this in mind when you're designing your system. What are my business requirements? For instance, from a failover perspective, are there any specific things that I need to keep in mind? ISE is a highly available system, but you have to take into account when things happen that are unexpected. Are there things, whether regulatory or business related, that are going to make a specific design decision one way or the other? For example, I have a big healthcare background. When we look at hospitals, hospitals have a requirement that the system be available even if the external connectivity is out. So what that basically means is I might have to have an ISE cube standalone in each hospital to maintain that. So just keep things like that in mind when you're designing your system. Obviously, the network topology and the latency, those are key things you have to look at with any application, right? So what makes up an ISE deployment? There are endpoints. So these are the things that are attaching to your network, whether they're workstations, headless IoT devices, doesn't really matter, just things that are connecting to the network. There's our network devices, and you'll hear the term NAD, which is network access device, used kind of interchangeably with network devices throughout this presentation. So those mean exactly the same thing. These are our switches, our wireless LAN controllers, the things that the users are connecting to gain access to the system. In essence, they act as a proxy to the authentication server. No endpoints directly connect to the ISE servers, they connect to the network devices that basically forward that information over to the ISE servers. There's our ISE servers, right? So pretty straightforward. These are our authentication servers. And then there's going to be some third-party systems that make up our deployment as well, whether they're external identity sources, such as Active Directory or LDAP or SAML. There might be mobile device managers. There might be external threat systems that we're integrating to as well, too. So in ISE, there are three main types of deployments that should fit most of your needs. And we'll talk about those in a little more detail on the following slides. ISE has different roles or personas that it can take on, whether it be an administrative role or a monitoring role or actually a radius server or a session services node. So these are basically, when we talk about personas, they are the roles that the server has in the environment, and we'll talk more about these a little bit later as well too. We have physical and virtual options. We'll hit on this in a little bit more detail, but basically there's no difference between the physical and virtual other than I have physical hardware for one and virtual hardware for the other. And then ISE can scale with its current version up to 2 million endpoints, and yes, that's million. There obviously is a requirement, so again, look at those release notes. This is with 2.6 and the new 3600 appliances, but it can scale really big in your environment. Again, that's a technical term. If we look at the hardware that's available out there, we've basically got three models that you guys will probably see out in the environment. The 3400 series are legacy. They should be phased out. You may still see a handful of these out there, but if you see these in an environment, these should be phased out. The 3500s are the mainstream, right? They're what you're going to see the most of out there. They are end of life and end of sale, but you're still going to see them out there as those are what's primarily deployed in most of the environments today. And then the newer appliances or the newest generation are the 3600 series appliances. They only run 2.4 and above, 2.4 patch 9 to be specific. So if you're going to the new platforms, you have to be on a newer version of ISE. So virtual has the same scale as hardware. The only difference is it's not a physical box. We talked about that a little bit already. One thing to note is it does require resource reservations. Resource reservations are basically where we reserve the amount of CPU, RAM, and disk space in the virtual environment. A lot of VM administrators don't like this and give pushback. However, I can tell you based on experience that if we don't reserve those resources, there will be small problems that crop up that are very, very difficult to pinpoint, and you may never really be able to pinpoint what they are. The way I like to equate it is, even though the VM environment is very fast at allocating resources on demand, the ISE database in the infrastructure on the backside is more or less a real-time application, correct? So with that being said, when I need to do something and I need the memory and the CPU to do something now, even if I have to wait a very, very small microsecond for that to happen, it's enough for ISE to blip. And again, the problems that crop up can be very, very hard to find. So please, 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 always, always reserve your resources. And if your VMware guys won't do that, do hardware in the environment. The other thing to note that ISE does not support is ISE doesn't support VMware snapshots. So keep that in mind as well too, and make sure you disable the snapshots in your VMware environment. Remember we talked about personas earlier. The 4 main types of personas we're going to be dealing with are the admin node. So this is the guy that we log into to do all of our administration of the system itself. He's also the replication hub for all the database changes. He's basically the brains of the operation and controls everything. The monitoring node is basically our logging node. All of the logging information from the system comes to the monitoring node, and the admin node will reference the monitoring node when displaying this in the user interface. He also holds the ISE session directory. So when I come on the network and I get an active session, there's basically a session record that's established and tied to that endpoint. The monitoring node holds this session information so that it can share this and reference this across the environment. The policy nodes. These are basically our workhorses. They make the policy decisions. They are our radius servers or our TACAC servers from a network device administration perspective. The PX Grid node is our integration node. It runs as a service on the PSN and allows us to offer that service up to third-party systems so that they can subscribe to services that we offer and we can publish that information out. So in essence, it facilitates the sharing of information between internal systems as well as third-party systems as well too. And the one key thing I want to make sure that's clear about the monitoring node is even though he takes the logging information in and provides that to us, he still holds some critical functions such as that centralized session directory that we talked about before, as well as the PX Grid topics that are published out. So if the monitoring node goes away, it's really a key component of the overall system. So just keep that in mind as well too. ISE is designed to be a highly available system. You'll need to have a basic understanding of these options to pass the exam, as well as design your own system. So let's talk about the PAN a little bit, that policy administration node, that brain of the operation. I can have a max of 2 of these in a deployment. They're active and standby. So there is an active guy that's serving out the user interface and he's managing all that data, and there's a guy that's standby that basically gets replicated data from the admin node and keeps that in sync so that if he has to take over in a failure scenario, he can. We have both automatic and manual failover options available, and we'll talk a little bit more about those as we go along. The monitoring node, again, there's 2 of these. The difference in behavior between these and the primary administration node is that both of these guys are active, right? So they're both getting copies of the logging information from the PSNs at the same time. The only difference is I do have a primary and a secondary. My secondary is read-only. Even though he's in sync with the primary and getting duplicate copies of his logging messages, he can't update things that need to be updated in the environment, such as the session directory that we talked about earlier. The PSNs, these guys are always active. These are basically our radius services. And there's multiple ways to configure these in a highly available scenario. And we'll talk about this before, but basically we can use the typical network access device, primary, secondary, radius options, or we can use a load balancer. We can also organize these into node groups. Node groups are basically used when policy nodes are adjacent to each other from a network perspective. And it allows us to facilitate sharing certain database information between the two and optimizing replication of those specific profiling attributes so that we can use those in a failure scenario. I've got 3 different deployment types. A small is a couple different things. All of our services run on a single server or a pair of servers. I've got a medium. Our admin and monitoring node are split out on a pair of servers dedicated to those specific functions, and I can have up to 5 policy nodes in the environment. This is a note that we'll talk about a little bit further, but this option isn't meant to increase scale. It's only allow you to be more flexible in where you distribute those authentication servers or the PSNs to. And then large is a fully distributed deployment where I've got dedicated nodes for admin, dedicated nodes for monitoring, and dedicated nodes for policy. And we'll talk about those in a little bit of detail as we move forward. This is our small standalone deployment. This is where all of our services run on a single node. The primary use case for this is typically a lab scenario where we're just labbing things up and learning on the fly. This will be what you'll want to use in your lab when you're studying for the test as well too. If we look at the number of sessions that is supported with this, that variable is on the left-hand side. So as you see, we go from 5,000 all the way to 50,000 just for this specific type of deployment. But again, because it's a single node, it's not highly available. It's really designed for a lab. The next one is basically the same one we just talked about. There's just a pair of nodes. This could be for a small deployment. Whether it's a branch office, a hospital, etc., this is where all of our services run on a pair of dedicated nodes, and they are highly available because they will back each other up. Again, this is for your typical small deployment. If I look at the medium deployment, I've basically got 2 admin and monitoring nodes. Those services are shared on a pair of servers, and then optionally, I've got 5 PSNs that can be distributed throughout the environment. Sometimes 2 of those nodes can be dedicated for PXGrid, or we can share PXGrid on those nodes. And as you can see from the session count, this session count looks the same as the standalone node from before. Again, this is not meant to increase scale. This is only meant to give you the flexibility to distribute the policy nodes throughout the environment should you need to do so to make them closer to the network access devices they're serving. This is our large distributed deployment. This is where we actually break this up even further. I've got 2 dedicated servers for admin, 2 dedicated servers for monitoring, and then I've got up to 50 PSNs that can be distributed throughout the environment. So as you can see, this scales very large and will grow as we need to in our environment. So when we talk about the max sessions for this large distributed deployment, as you can see, we scale anywhere from 250,000 to 2 million. And the 2 million is on the newer hardware with the newer version of code. The scalability numbers are platform dependent, so please keep that in mind when designing your environment. And last but not least, in an optional design decision, we could have 2 dedicated PXGrid nodes that serve up this environment. Now, we talked about load balancing the radius services just a little bit. We have a couple different options. We can use the network access device's radius configuration of primary, secondary, and just let it kind of do its thing. Or we can decide to load balance the policy nodes behind a load balancer so that we front end it with a virtual IP. Pluses and minuses to both. And it really depends on your requirements from a user experience perspective in a failure. For instance, if we use the radius configuration on the network access device, in a failure scenario, there's normally some timeouts that have to occur, which could lead to some delays in users being authenticated to the system. We can solve that by putting the servers behind a load balancer that has health checks on the backside that will very quickly switch from one server to the other in a failure. So again, both options are available to you, and it really depends on your environment and your requirements.